So, hi everyone. I'm Sutton. Some of you may know me, may not know me, but I work for a company or co-founded a company called Snapp Automotive that was a spin out from a company called Snapp Mobile that was a mobile development agency that has been around for 6-7 years. And they started to become involved in automotive projects and realized that the pace of automotive and some of the practices used in automotive development had some room for improvement. And then Android Automotive OS came along, which was kind of the aligning of everything that would work for Snapp Mobile happened because they were already well versed in Android experience. They knew how to develop apps. They had lots of designers. It was a really good thing. My background is I worked for a while at Google on the Android team. I've been involved with Android since its public launch. I've worked on firmware. So I joined the guys who'd set up Snapp, and that's where Snapp Automotive came from. So we work from the firmware right the way up to apps and Android Auto apps as well. Android Auto is that weird beast it's kind of not really a mobile app, not really in car, but it straddles the two, and I'll talk about that in a bit. So, app developers developing apps on Android Automotive OS. This is something that a lot of app developers find difficult to get started in. It's something that they find, I wouldn't say so scary, it's just a whole chunk of knowledge that a lot of developers overestimate. So they think that developing apps for cars is going to be, or any type of vehicle, is going to be a massive amount of learning, a massive amount of new skills, a massive amount of new things they've got to grips with. And so a lot of the work that as firmware developers we can do, and as app developers, is just make it not a scary thing to approach. So folk don't think that they're going to be spending several months knee deep in documentation before they can even put hello world on the screen. It's realizing that developing apps, particularly when the car is parked, is very similar, if not the same, as developing a good tablet app. When you're in motion, there are a whole bunch of other things that you need to worry about, but the things like Netflix and all the streaming apps and even hotel booking apps, things that you're going to use when stationary, a lot of the time they are using the same principles as you would for a app for a tablet. So what the assumptions a lot of app developers come with is that the application is going to be sandboxed. They need reassurance, and sometimes this is the hardest thing to convince app developers, is they're not going to cause the doors to pop open while people are driving at 70 miles an hour or 120 kilometers an hour. There are a lot of things in place, particularly with Android Automotive OS and separating it from the real-time OS. That means that if you're putting an app to display some text or pull some data from a website, you're not accidentally going to make a call that's going to cause the car's brakes to suddenly come on, or it suddenly starts steering in strange directions. That's hidden behind a lot of permissions, and it's the first thing that folk need to get confident and comfortable with, is that you're not going to break it. There's also the assumption a lot of app developers make that their UI will scale automatically. And this is always an interesting assumption, because a lot of dashboards are very, very obscure aspect ratios. So we're not talking about 16:9 or 4:3 or anything else like that. We're seeing some that are 21:5. We're seeing concept designs where the whole dashboard is just one long screen. And if that's something that's treated as a single screen by Android Automotive OS, letting app developers know that their app, the UI, which scales on a tablet nicely, may not actually look great in the car, is something that is worth flagging early, because it's a shame to see them do a lot of work and then suddenly put it into a car that they've got a bundling deal with, only to realize that it's going to be letterboxed. It kind of spoils the whole experience. The other thing that the app developers like is the platform being stable. I've worked on projects with one manufacturer who were trying to portray themselves as having an Android platform, when in actual fact, they were sourcing the hardware from different vendors. Those vendors were providing the firmware builds. And when you ran the same app on different versions of their platform, you would see different appearances. So things like title bars on Windows, or certain video codecs working on one but not the other, and things like that. So app developers want the platform to be stable. They want to know what they're getting. And it's a common assumption they make that it's going to be ARM based. Now, the Polestar 2 is based on Intel. So that's a shipping car. That's shattered that ARM illusion. But Intel a long time ago gave up the mobile space. They gave up phones, tablets, those kind of things. So a lot of app developers coming to Android Automotive will not realize that Intel is still a thing. You can't ship something with ARM only libraries. And particularly for games, this is something that we've seen, is that the moment you try and put it into a Intel based system, it'll just say, no, it's not supported. The other interesting challenge that's coming is that for a lot of Android developers, Android app developers, they're only focusing on 2 or 3 historical releases. This is largely driven by Google, who are pushing the Play Store listed apps to be to target at most a year-old version of Android, 2 years old if you're lucky and you have a good relationship. 3-year-old version of Android, you're likely to be delisted from the Play Store. So a lot of app developers will not be thinking about the lifetime of a car as a 10, 20-year thing, and thinking about the upgrade path for Android over that time. So there are also some red flags from talking to app developers we've seen. Custom APIs are a big one. The thing to remember is even the largest automotive conglomerates, people like the Volkswagen Group across all of their brands, are shipping less vehicles in a year than the biggest mobile manufacturers ship in a month. So in terms of how many users the app developer is going to reach, vehicles are not a big thing. If they have to spend their time focusing on mobile or vehicles, they will probably spend it on focusing on mobile devices. So if you say to them, oh, well, to get going on our platform, you've got to use these custom APIs, you're instantly adding a sort of red flag. That's a bunch of stuff that is very tailored. And there are publishing channels where if every different automotive brand had their own publishing mechanism for distributing apps, app developers aren't going to go and use those. If you look at it in the mobile world, and I always draw an analogy of we're kind of in the 2010, 2011, 2012 era of mobile apps, when there were Vodafone, Samsung stores, Huawei store, everybody had their own app store. But what you see is app developers not really supporting them. So someone like Samsung's own store, it's very sparse in apps. And even Amazon, who ship devices that don't have Google Play, and they have the same kind of captive market that automotive manufacturers have, the number of apps you see in the store is very limited. So having a custom publishing channel to get into an app store that has a very small target market for 1 or 2 brands of automotive vehicles is very difficult. And custom permissions are another thing that app developers have concerns about. Basically, it's any additional work. If they're going to have to do something specific for cars, they are likely to step back from doing it. And we've seen this even with very big players. We've seen large app developers telling large automotive manufacturers that they're just not going to do any work for 6 months just to see how things play out. So as firmware developers, the closer we can stick to the Android APIs and the less we can add extra services that we need app developers to use, the better the experience will be in getting app developers onto the platform. So as I was saying earlier, old is very old. In the mobile world, 3 years is a long time for a device. 4 years, you're unlikely to see the hardware supported. 5 years, you're lucky if you're still seeing updates. If you bought a Fairphone phone, you're likely to be in a good place. If you've bought a generic Samsung device, 5 years down the line, you're lucky if you're getting security updates. Now, if you compare this to car life cycles and vehicle life cycles, where you're talking 5 years, you're probably on the second owner. 10, 15 years, the car's still on the road. For a lot of app developers, that long support cycle is something that they need to be aware of and they need to be thinking about. And it's something that Google has not done a great job of supporting so far. They've been producing new versions of Android and they've been saying your apps in Play have to support 1 or 2 previous versions of Android, but they haven't yet reached the point where cars are stuck on a version of Android that's 5 years old. No one's scrapping their car because the version on the head unit isn't good. What we've seen is that people are likely to just switch to using Android Auto or even that CarPlay thing instead of using the IVI, instead of using the interface that comes with the car. And that's an interesting backup. But as a firmware developer and as a brand, you've lost the user. So there's this whole question of where do firmware developers go? Where do car manufacturers go to support app developers long term? So for most app developers, as I was saying, they think of the car as a large tablet and they think that their tablet apps are going to work. They may add some features in to read some of the properties from the vehicle HAL and things like that. But a lot of the first iteration of app development that we're seeing is what I'd say is boring. It's tablets apps ported across. It's not making use of features in the car. It's not closing the sunroof if the weather app is saying it's going to be rainy. It's not warning you that your windows are open if it's going to be if it's an area where you're suddenly going to be seeing high winds and things like this. So this as a first iteration is great, and it's the kind of toe in the water first step that we see. But going into more complex thing is an area where app developers have got a lot of opportunity. They can make use of the car's features in interesting ways. So imagine a game where every time you had a pit stop in a racing game, you had to open the driver's door, run around to the passenger's door, open the passenger's door, shut the passenger's door, run back to the driver's seat and sit back down. You're adding this whole interactive element that you wouldn't get from a tablet app. So there's a lot of opportunities, but to get developers to write apps that make use of these things, we need to create good documentation. We need to make this easy. And the custom API approach is something I've seen some manufacturers consider, but it's not going to be something that app developers will take up. It's better to do custom properties via the car manager and use the APIs that exist and supplement them with a few extra custom properties that give you access to all these interesting things that unlock this functionality. So what does Google provide? Google provides a reference that says, go and talk to Volvo. It is probably the most poorly supported application development target I've ever seen. The fact that you go into Google's documentation and they say, hey, here's an image from Polestar and here's a Volvo system image and good luck to you with that, is missing out on so much. At Snapp, we provide some emulator images that are stock AAOS from the AOSP with a very small OpenStreetMap wrapper app in it, because an application, a car OS without a map is very limited. And if you build AAOS from the AOSP repos, you get this green box that just says, yeah, can you put a map provider in here? Which is why we wrote probably 100-line app that just puts the OpenStreetMap map in there. It's not fantastic, but it at least gives everyone access to a common base. The Polestar and Volvo system images are tailored to the Polestar and Volvo display ratios, the aspect ratios, and what they're looking to do. And even those now are not reflecting things like the Polestar 3, and they're certainly not reflecting some of the screen dimensions we're seeing in some other manufacturers. So there is this question of whether Google is is committed to supporting app developers for this. And this is kind of even reinforced with, if you don't want to go down the route of using Volvo's images, and Polestar being essentially a brand of Geely and Volvo, it's the same manufacturer. They tell you to go and download the standard Atom Intel image for automotive, which is based on Android 9. That's 4 releases out of date. We're on Android 13 now. Android 14 is coming out this year. So Google does not really provide a good story for developers to transition into automotive development in an easy way. They're basically saying, use a version of Android that we support that is already 4 releases out of date and doesn't support most of the recent APIs, or you can go to a single automotive manufacturer and hope their system images are pretty good. So this is why we provide AAOS, AOSP emulator images. It's because we want to see the app market expand in cars. We want to see these cool things done, but Google at the moment isn't providing it. But Google do provide templates, and this seems to be where they're focusing most of their effort. The templates are really focused around in-motion apps, and Google's attempt to provide a driver distraction-free way of implementing applications. So this is largely the navigation stuff, which makes Google Maps a more valuable proposition. So it's one reason why Google would be putting a lot of effort in here. But they're quite limited. App developers who use these generally have to give up their own app branding. So you could be using an EV charging locator, and there's very limited branding about whose charging locator you're actually using. And it's generally not something that app developers are adopting en masse. There is also the problem of, as I mentioned earlier, it seems like a steep learning curve. It seems like a whole new environment. It's not quite that bad. You can use a lot of the back end code on the client, so networking, databases, all that kind of stuff. This is very much at the presentation layer, the view layer. So it's not as bad as it could be, but it's still a large amount of knowledge that most developers are worried about. And we have engineers who we ramp up on this, and it usually takes them a week or two to get to a place where they're writing productive apps. Now, the template engine is part of the AOSP, but if you try and run it, this is our Snapp OS. If you try and run templated apps, what you quickly find is without Google Maps, they really don't work well. So you might be able to get the media services to run, but anything that requires any kind of map backend to it, you'll come across an error saying, you've not got Google Maps installed. And very few, if any, map providers ship an APK that is compatible with the template. So the templating engine is really locked into Google's whole environment. We're looking at fixing that. We're looking at producing open source things that can supplement the templating engine that you get out of the AOSP and provide you with a meaningful experience. But for Google, their answer is always going to be use Google Maps. So if you're working on firmware which is not going to have GIS in it, it's worth thinking about what your story is going to be for templated apps. How are they going to be supported? Are you going to enable people to come across really quickly? So then we go on to the next step, which is app developers actually developing the firmware itself. So this is something a lot of people go, why would you do this? Why would you get an app developer writing firmware? What are you kind of trying to do? And for a lot of companies, they will take Android engineers from anywhere that they can get them. They have a lot of experienced firmware people who are Linux focused, but Android is a non-POSIX system. So there are some interesting challenges in just trying to take Linux code and run it in Android. I have worked with one vendor who wanted to take the Linux JRE, stick it into Android and assume their app would just work. That was not a happy journey. So for a lot of companies, the abundance of Android app developers means that if they can use them for developing firmware related applications, they're going to try it. So this is my call out, whatever you do, if you come across an app developer and you want to get them into developing firmware, don't start with introducing them to AIDE, all those kind of good tools that you deal with in the firmware. It will scare them. There are a lot of app developers who will just go, okay, I no longer understand how I'm doing things because I've got to wait an hour and a half for a full build. Then I've got to build some tools. Then I'm using this AIDE thing, which generates a view of the source code, which doesn't have 3 or 4 levels of dependencies available. So some of the things say they're unresolved, but they actually do compile and all this kind of stuff. It's better to give them a smoother ramp in. And we do that at Snapp by giving them the ability to write an app, and then in our firmware using the SUNG target of Android app import. So they create an APK, and then we just include that APK in the build. This gives them a lot of comfort because they're using the same tools, they're using the same CI systems, they're using APKs that can be distributed outside of the firmware, so they don't have to build their own complete firmware to do this. And it reduces the demand for OS level modifications because they are no longer so deep into the firmware development that they think, you know what, I'm just going to add in a new service to systems, the system services, and I'll call that, and then I'll have access to all these things that are supposed to be privileged functions. And developers can use newer libraries than the OS. So they can use the most recent version of Compose and other things like that, which for them is very beneficial because app developers like to use cutting edge versions of libraries because it makes sure there are fewer bugs. It makes sure they've got the latest cool features and all this kind of stuff. So what kind of libraries am I talking about? Compose is a big one. Compose is Google's latest, greatest way of writing UIs, and it supports API level 21 plus. Kotlin is something that didn't exist when the first version of Android was released, but because it can compile down to Dalvik code, you can actually use it on API level 1. And dependency injection frameworks like Android Hilt or Android Dagger Hilt or Dagger Hilt, depending on which one you prefer to call it, it can create apps that run on API level 1, but it is something that is very, very recent. And so you can use things like these and technologies that haven't even been released to create APKs that can be bundled into firmware that is relatively old. So Android 9 could support a Kotlin written app with Android Hilt and a Compose UI on top. This is something that if you were part of the OS itself, it would be very difficult to do because you'd have to wire in all those dependencies, you'd have to make targets for it, or you'd have to make sure that the transient dependencies are compatible, and it becomes a bit of a headache. So this is why we have multiple developers who just produce APKs, or just app developers, and then we bundle those into the firmware. The challenges they face are if you go down to the firmware level stuff. And when I say firmware level stuff, we have developers who are app developers who don't get involved with firmware, who are developing system UI, and the system UI is written in Compose. But the challenges they face is multi-user environments. They tend to consider their app as running in a single user profile. So things like theming engines, we have a theming engine, but having a consistent theme across all users is a new challenge for app developers because it's something they don't usually look at. And the memory overhead for critical components. Throwing Kotlin code into every single APK that's part of the system is not going to be a nice journey because you end up with the standard library being thrown into those apps as well. And you see apps bloating out. It's the same thing with if you're using any new app. Zygote will put into memory that base version of a library, and if you're using a different version of the library, you may get class incompatibilities. So you don't want developers suddenly saying, you know what, I'm going to write a system service, but I'm going to use this version of Compose, and then suddenly finding that a version of Compose is built into a critical core component that causes class path problems. And forking existing repositories is a nightmare we need to worry about. If we can isolate the APK, we don't need to worry about forking an existing OS repository, AOSP repository, and then having to merge in all the security fixes and new releases and all this kind of stuff. So this is why we go down the route of using APKs and bundling them in. So I am 3 minutes short. I will look to Chris to tell me whether that's enough for Q&A or whether he wants to do a joint Q&A session at the end. What do you feel like, Chris?
Okay, well, that was fantastic, useful information. I've been making notes like crazy here. Yeah, let's do Q&A now. I'm happy to, I prefer to do the QA directly afterwards, otherwise people have forgotten. So we can overrun a little bit. There's nothing, there's only me afterwards, so that you can skip that. So
you're a generous speaker.
So let's open the floor. Anybody have any questions for Al?
I will have a question.
Someone?
Yeah, thank you. So you mentioned the problem of getting app developers develop apps, system apps potentially. Now I had a similar problem, but we can't just build APKs in Android Studio that use system APIs, right? Because they're not within the official Android SDK.
You can. What you can do is you can create a custom SDK, and you can put that into Android Studio as an additional SDK for the API level. And then you can reference it and get access to all the system APIs. Google is doing some work in this direction with some of their latest build changes, so that it allows you to generate stubs of the hidden APIs. But if you're willing to distribute a custom SDK, which we do internally, we distribute a custom SDK, we put that into Android Studio, and that gives us access to everything. So system UI is something we actually develop in Android Studio in our mono repo using the SDK that we've created that includes all the hidden APIs. And that SDK is created just by copying a jar out of the build.
Yeah, one follow-up question, that custom SDK that you built then, is it that you manually remove like the system API annotations, or?
Nope. What we do is we get the jar before the annotation processor runs across it, because all that happens with the SDK jar is that the annotation processor runs across the code and removes all of the APIs marked as hidden or system. We just get the jar from before that process happens, drop that in as part of the SDK, and then you've got all of those APIs available.
Awesome. Thank you very much.
I actually had the same question, but a bit more to elaborate. Where do you get the jar from? Is it some intermediates folder in?
It is.
In build output?
Yeah, it's an intermediates folder. What I can do is I can share in the Slack channel that I'd advise everyone to join. Later, probably tomorrow now, I will share our instructions on what we do to build a custom SDK, and that includes telling you where to find that jar that's not been processed by the annotation processor.
I have my question around. We are doing a similar process to have access to system level APIs. Once we build our applications, and when I decode the jar file and look into the sources, I can see that stubs are actually in the APK file itself. So how it is actually working on runtime? Is Android loading those classes from operating system first, because they are same class with the same exact package name, but one of them is full of stubs and the other one is the actual class file? How it's actually working behind the scenes?
So if you replace the SDK, the stubs shouldn't be included in the final APK. So your custom SDK is, in Gradle terminology, a compile-only dependency. And Gradle allows you to specify these compile-only dependencies which are not bundled into your final release. If you're seeing the stubs in your APK, I would think that there may be something wrong with how the dependency is being referenced, because it's not being referenced as a compile-only dependency. It sounds like it's being referenced as an implementation dependency. So I'd check your dependencies in Gradle to see how you're actually referencing that stub jar.
Okay, that might be, but it still doesn't explain how it actually works in this wrong way. I mean,
I don't know how it would work. Having two classes with the same package is into the areas of undefined behavior. So if you have experience, you would know more than me.
Okay, I will check my dependencies.
And you can tell us all in the Slack channel.
Yeah. Thank you.
Okay, anyone else? Okay, cool. Well, let me say, first of all, thank you very much, Al, for a very informative and interesting presentation. I'll be putting the slides and the presentation online tomorrow. And if anybody does have some follow-up questions, as Al mentioned, we have the Slack channel. So yeah, let's make use of that.
Great. Thanks everyone for listening, and I hope you all found it useful.